Hey everyone, welcome back from the weekend. We're going to be picking up where we left off. We had just started talking about the Bonshoff Power Index, and we looked at an example last week on Thursday before the quiz on how to calculate the amount of power that each individual player has in these weighted voting situations. All right, the Bonshoff Power Index gives us a lot of information about the amount of player that each or the amount of power that each player has. And today, what I'm going to do in this second example is not only are we going to calculate the power, but we're also going to learn how to use this information to quickly identify players that are dummies, dictators, and who might have veto power. All right, so let's start off this example. We're going to look at the first step to calculating the Bonshoff Power Index is identifying all of the winning coalitions that exist. Now, this one had more players than the last example that we did. And remember, the strategy that I told you is to go through and list every coalition, whether it's a winner or not. All right, and then go through each one and eliminate the ones that are non-winning coalitions. So you might create all of the 5-player coalitions, 4-player coalitions, 3-player coalitions, like list them all, and then just start eliminating the ones that are not reaching quota. All right, so remember, they have to have a grand total of 16 for their weight to be a winning coalition. So if they don't, you just eliminate them from your list and then move on from there. So I did that, but I did that outside of the video, right? Because it's a very tedious process and it's very boring to watch. So I got to this point here where we have the winning coalitions. This is what I had left after I eliminated all of the losing coalitions. All right. So if we look at player 1, player 2, and player 3, if they were to team up, they would get a grand total of 16 votes. Same thing with player 1, player 2, and player 4. So we just go through and add them up, right? So player 1, player 2, 7, 6, and then player 4 has got 3 votes, so that would be 13 plus 3, which is 16. So that's where I'm getting these numbers from. I'm just adding up their total weight. Okay. Then for player 1, player 2, player 3, player 4, they have a total weight of 19. This next one, player 1, 2, 3, and 5, they're going to have a weight of 18. And then player 1, 2, 4, 5, they also have a weight of 18. And then if everyone were to team up and say, yes, we want to pass a measure, they would have a grand total of 21. So that would actually be the total number of votes that we have there. All right, so I've got all the winning coalitions listed. I know all of their weights, and now the next thing that I want to do is I want to count up how many times each player is critical. All right, so if you're a critical player, that means inside of a winning coalition, if you were to leave that coalition, they would go from a winning coalition to a losing coalition. Okay, so that means if you left and their total weight dropped below 16, then you're critical. All right, so for instance, in this coalition, they have a total weight of 16. If player 1 was to leave, they would lose 7 votes, so they would go down to 9 total votes, which is not enough to make quota. So that means player 1 is critical, and I just circle them. Okay. And since their total weight is 16, that means anyone that leaves is going to drop them below 16. So they are all automatically critical here. Okay, so I'm going to circle them all. They're all critical. And same thing in the second one. Their total weight is 16, so if anyone leaves, they're going to drop below the quota. So I'm going to go ahead and circle them all again. They're all critical. All right, then I go to the next one. Now this one has a weight of 19, so anyone that has a weight of more than 3 is going to be critical. And the only 2 players that have a weight of more than 3 is player 1 and player 2. So I'm going to circle both player 1 and player 2. They would both be critical, but player 3 and player 4 are not. They both have 3 votes, so if player 3 were to leave, it would go down to 16, and that would be okay. And then if player 4 were to leave, it would go down to 16 again. So player 4 is not critical either. All right, so let's go to the next one. They have 18 votes. So anyone that has more than 2 votes would be considered critical. And that would be everyone except for player 5, right? So everyone's going to get circled. So player 1, player 2, player 3, but player 5 is not going to be critical here because player 5 only has 2 votes. All right, going on to the next one. 18 again. So again, more than 2 means you are critical. So player 1 has 7, so they're critical. Player 2 has 6, so they're critical. Player 4 has 3, so they are critical. But player 5, again, not critical, right? Only 2 votes. All right, now let's look at this last one. We have 21 votes. So to drop below 16 here, we would need more than 5 votes, right? So that would be player 1 and player 2. Player 1 has 7, so if they left, it would not be a winning coalition. Player 2 has 6 votes, so they would be critical, and the rest of them would not be. They don't have enough votes to drop that below 16. Okay. So now we see all of the critical players in every single winning coalition. And what I want to do is I want to count that up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of times that any player is critical is 16. Okay. So we have 16 total. I'm just going to keep that number off to the side for now. All right, and then we're going to go and get individual tallies. So like how many times was player 1 critical? Well, 1, 2, 3, 4, 5, 6. Okay. Player 2 was critical 6 times. All right, player 3 was critical 2 times. And player 4 was critical 2 times. And then player 5 was never critical, so 0. Right? And again, the total of all that was 16. Right? So it's going to be important later. All right. So now to figure out the actual percentage of power that you have in a weighted voting system, you take the individual tally and you divide it by the total number of times that anyone was critical. So for instance, player 1 was critical 6 times out of a total of 16. Okay, so that would create a decimal of 0.375, which converted to a percentage would be 37.5%. So player 1 had 37.5% of the total power. Now player 2 is going to have the same exact calculation because they were also critical 6 times out of the 16, giving them a 0.375 and 37.5% of the power. All right, player 3 was critical 2 out of the 16 times, for a decimal of 0.125, which converted to a percentage is 12.5% of the power. Now, player 4 also was critical 2 times out of the 16, so the calculations will be exactly the same again. And then player 5 was critical 0 out of 16 times, which is going to be 0 and 0%. And again, if I were to add these up, these should add up to 100%. If I add the tops of these fractions up, it should add up to 16, which it does. So they both check out. I didn't miss anything. I have all power accounted for. So now we know the power distribution here for each player. And it gets interesting because when you look at player 1 and player 2, they both have the same amount of power according to the Bonds-Hoff Power Index. But if you recall, they did not have the same number of votes. So player 1 had 1 more vote than player 2, but yet they ended up with the same amount of power. Now player 3 and player 4, right, both ended up with the same amount of power, and they had the same number of votes. Okay. And then obviously player 5, another interesting scenario here, has 0% of the power. They have absolutely no power in this weighted voting situation, yet they had votes. They had 2 votes, but it doesn't matter because they were not critical in any of the winning coalitions. And if you remember the definition of a dummy, okay, a dummy is not essential in any winning coalition, and that is what player 5 is, right? Player 5 is a dummy. So I'm going to make sure I write that down real quick. Right, because that was one of the things they asked, who's a dummy, right? So player 5 is a dummy. He has 0% of the power, right? So if you end up with 0%, you're a dummy. All right, who has the most power? Well, player 1 and player 2 do. Right, they kind of tied for it. So they tie for the most power in this particular scenario. And the other thing that I want to note is, does anyone have veto power? So if you remember our definition of veto power from earlier, if anyone is essential in every winning coalition, if you're essential in every one of them, right? So here's all the winning coalitions. I listed them out for you. And you'll notice player 1, right? Player 1 is essential in every single one. So is player 2. Okay, so none of these coalitions could be successful without either player 1 or player 2. So they have veto power. You cannot pass a measure without player 1 or player 2 being on board. Okay. So you would have to have both of them. So player 1 and player 2 have veto power. Okay. And you start to see some of the benefits of this Banzhaf Power Index is it gives you a really good detailed analysis of who has the power in the weighted voting situation, and it makes it really easy to see who has veto power and who's a dummy. Now obviously no one here was a dictator. I know I would talk about dictators as well. If anyone was a dictator, the Banzhaf Power Index would have that dictator with 100% of the power and everybody else would be dummies. So you'd have 100% and 0%. All right, it'd be kind of a boring calculation for a Banzhaf example. But, all right, guys, that's enough for today. Go try some of the practice problems. Make sure you get that Banzhaf Power Index process down. If you have questions, make sure you let me know in the Zoom chat. Have a great day.